Hello, welcome to another Hackers Teaching Hackers CTF 2021 solve video. In this video, we're going to be taking a look at the third crypto problem, and that problem is going to be the Oracle of Time. The Oracle of Time is an interesting challenge that gives us some information and hints as to what's going on. The Oracle of Time was really a hint to the fact that this is a timing oracle. An oracle is essentially something that gives us information about a detail that we should not know. What this can end up being is something like a padding oracle attack in cryptography, where if we don't have correct padding, the software will actually give us an indication that our padding is incorrect, and we can use that information to attack the algorithm. Other things that we can do in timing is if something is processing something and it's taking a long time could be relative, but if it's taking, let's say, we'll expand it out to seconds. If I give an input and it takes 5 seconds and then I change my input and it only takes 3 seconds, something is wrong there, right? So what that could tell us is that if it's processing on spinning on it longer, then we may have more of the code correct than if we don't, right? Then it's less. And I'll show you what that means. So first of all, I'm going to go ahead and copy this and we're going to connect to this guy. This is from the previous video. So I'm going to put this up here. It's going to tell us to enter a code. So I type in some code and it tells us too short. Okay. Stoke is the name of a character in the like story mode of this. So first of all, this is an indication that something's wrong. I should just say incorrect input. But if it's telling us that it's too short, then that's a problem. And it also tells us it's too long. So what happens if we get to the point where it's not too short and it's not too long? It should be the exact thing. And I think this is 27. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. All right. Standby Stoke checking code incorrect. Okay. So what's interesting there? Well, again, we know that our code is incorrect, but we have this whole timing thing, right? If we go to, and there's some leaps of faith here in a sense that you have to kind of know what a timing oracle is and the fact that there could be a time dependency on our input. If we go and take a look at how the flag formats is, it tells us that HTH followed by curly braces is what everything should be formatted as. So let's go ahead and do the same thing again, but instead of doing this, and of course that's not going to work. What if I do HTH curly brace, and then I try to get this right, HTH curly brace, this, and then run it. Incorrect. So did that take a little bit longer? Well, let's do time. What we're going to do is we're going to time this command and see how long it takes to actually run. And this is actually not going to work very well because I need to echo this thing out. So what I'm going to do is I'm going to do echo. Yeah, clear the screen here. I'm going to do echo and then the thing that I want to send, which in this case will be this, and I'm going to send it to the correct netcat endpoint here. Oracle of Time. This guy through here. I'm going to say standing by, incorrect. I have to time that, so let's do this. All right, so 2 seconds. If I do this, 1, 2, 3, 4, 1, 2, 3, 4, replace it with ones, it takes like no time at all. So if I come back here and add the first H, okay, took about a half a second longer. And then if I add in my T, it takes about a half a second longer again. And if I add in my H and this, it takes about a half a second longer, or it should. Then I can go to the last one and see that, oh, it's taking, again, another half a second longer. So what's happening here is everything that it gets correct, it is ending up taking a little bit longer. So it takes about half a second to verify which one. It doesn't matter which order you get them in. If you get the correct in the middle, it'll still take a half a second longer. This is useful for also side channel attacks. So if you're checking the amount of emissions or energy consumption in like a chip, and you're able to see how long an algorithm actually processes or works on, if it's working on something and it bails really quickly, that could be indication that the key or the flag that you're trying to enter or process is wrong. And as you keep putting inputs and doing these tests, you can see those emissions taking longer and longer or being higher and higher in magnitude. And that can help us actually recover certain things that we're looking for in hardware reverse engineering. So This type of software attack could totally be that type of case. And these types of things are what we are looking for. We're looking for any oracle or any hint at the fact that we're getting closer to what we'd want to do. So I believe if I start doing this, and what you can do is actually create a solve script to do this for you. So what you would do is you would connect to the service, time how long it takes to get a response back, and then instead of, you would do the HTH and you would start at A, check the time, go B, check the time, C, check the time. And if you get over a certain threshold, say that's right and move on to the next one. Or you can just do it by hand. So that was T, you would do A, B, C, D, E, F, G, get to I. Then it'll end up being like 3.5 or 3.6. So that's the case. And then we'll keep doing this over and over and over again until we find the actual solution, which I won't take you through that process. And that will end up being time can tell us a lot. This is the actual solve, the actual challenge there. And that's it. So the challenge kind of works like the last one that we did, which was come out to play, where we scripted this input that would connect to the service, send some stuff, and wait for a response. In this case, we could just blast some message at it and time how long it takes to get back to us by using timing functions in Python or whatever you're using. You could just Google that and find it in Stack Overflow. But that type of solve script will automate this whole thing, and we can create a map of like A through Z, numbers, capital A through Z, and we can enumerate that whole thing. And once it takes a little bit longer, maybe, you know, we can say a quarter of a second, half a second, something like that, in the last attempt, then we know we got the next one right, and we move on to the next one, the next one, the next one. And then eventually we'll fill out the whole flag, which is what we want to submit to the server. So hopefully that made sense. The next one, attacking codebooks, is probably the hardest challenge in the CTF, maybe the first or second hardest challenge, and nobody solved it. This is a hard one that you would have to look up, read some research on it, and try to figure out how this attack works. And we're going to go through that next. Hope to see you then.